Vibe coding is probably the hottest trend right now in the software industry. Instead of manually writing every line of code, we can now describe what we need in plain language and let AI agents generate code, run tests, perform some, if not all, SDLC operations and whatever else we might need. And that's great, since it means that now it is socially acceptable to talk to your computer. Like, hello precious, can you write a web app based on the OpenAI schema defined over there? Please be so kind to fix this issue for me and make a patch release. Or would you mind working on that problem for a while longer? There is even a button now in VS Code that enables us to literally talk to AI through a microphone. Vibe coding is, in a way, still coding. We generate instructions for machines and those instructions are interpreted into binary code. The major difference is in the language we use. With normal coding, we do not become proficient just by writing code. We become proficient once we learn the rules, understand best practices, and practice a lot. It's the same with vibe coding. The more we practice it and the better we understand the rules, the more proficient we become. So, today I want to share my best practices for vibe coding. They're mine. They work well for me. And I'm very curious to hear your thoughts. But before we jump into those practices, there are a few important notes that will set the scene for what we'll explore soon. First of all, with vibe coding, significant part of our burden is transferred to AI, but at the same time, we are getting additional responsibilities. One is not only a developer or an operator or a tester or a platform engineer or whatever one might be. Instead, we are becoming a combination of roles. We're a project manager. We tell AI what to do and when to do it. We're a product owner. We tell AI what the product should look like. We're a senior developer. We jump in when the task is too big or when it gets confused, just as we would normally do with junior colleagues. We're a PR reviewer. We have the final word whether the work AI did is ready to be merged to the main branch. Second, I do not believe that we should rush through work. AI speeds us up, without doubt, but also tends to create mess if we let it go wild. It is important to keep an eye on what it's doing, correct it when it goes astray, or sometimes even stop it completely and finish the work without it. By rushing through it, we often end up with garbage and might realize that we need to spend more time cleaning it up than doing the actual work. Slow is often faster, even though slow is now much faster than the fast was before. Finally, the last note is to not fall for silly marketing. Do not fall for, hey, look at me, I'm creating a new silly game type of hype. Do not believe people who say that AI can do the real work unsupervised. AI is great, but not that great when working on real apps. Real apps are much more complex than yet another variation of a Tetris game done from scratch. So, please keep those notes in the background of your mind while we go through best practices for vibe coding, since quite a few of them assume at least one of those. If you disagree with any of those, you might find some of the practices here to be nonsensical. Now, without further ado, let's go through the best practices. I do not know how many I have, but I do know that they will not be presented in any significant order. The only organization I have is to put them into groups. We'll see those I apply when I start a new session, those related to development itself, then practices for managing memory and context, and finally, a mixed bag of those I could not easily categorize. Speaking of AI speeding us up, there is one critical piece that makes this magic possible: powerful GPU servers. And that brings me to today's sponsor, UpCloud. If you're building with or fine-tuning AI models, running inference, or deploying AI agents, you need solid GPU power. UpCloud's NVIDIA L40s GPUs are available in their Helsinki data center for now, with straightforward hourly pricing and no hidden costs. Plus, they offer free data transfer, which is huge when working with large datasets and models. Use the link on screen, somewhere around here, for $50 in free credits and 30 days extended trial. So, big, huge, massive thanks to UpCloud for sponsoring this video. And now let's get back to where we left. There we go. Now, let's start from the start. When we start vibe coding, we start it in a new session. And that means that the agent knows nothing about us, about our way of working, about the project, or anything else related to us, to me, to you, and what we are working on. So the first thing I do is load all the instructions from a memory graph. That instructs the agent what I like, how I work, what it should do under specific circumstances, and so on and so forth. This step is essential. Without it, we would need to spend too much time explaining to AI things we already explained in the past. For example, over here I have a cursor rule to fetch MCP memory instructions, so all I have to do is call it. That, in turn, instructed the agent to read the whole graph with instructions accessible through the memory MCP. The rule itself is simple, and it is the only rule I have. It says, retrieve and process all information from the memory MCP knowledge graph to guide our session. Use memory MCP server for any task related to your memory. That over there is the only rule I have. I don't need any other since everything is now loaded into memory. From now on, the AI will know how I like to approach development, what to do with testing, how to approach releases, and so on and so forth. By the way, if you're not already familiar with memory MCPs, you'll find examples of the one I'm using in that video over there, so check it out, it's in the description as well. Next, loading the instructions that represent my development workflow is not the start. It's what happens before I start. Before we even start doing anything, we should have a detailed vision and description of what we need. Without it, we don't know what we want. And AI does not know what to do. As a result, we might easily end up with random garbage. So always start with a detailed product requirements document or PRD. In this specific case, I want to develop integration of my app with LinkedIn, and I wrote a relatively detailed PRD. There is project overview, there are automation objectives, there are technical implementation requirements, there is implementation strategy, and finally there is success criteria. The more detailed PRD is, the more likely it will be that the agent will do the right thing, and there will be less need for me to correct it during the development phase. Detailed PRDs make a huge difference in the final outcome and the time spent to get there. Now, to be honest, I did not write all that myself. I did it using Taskmaster, which I explored in that video over there. That, however, is still not where development starts. Once I choose which PRD I want to work on, I create a plan of all the steps required to develop that PRD. That plan is a list of all the tasks that should be performed by the agent. Those are even more detailed than the PRD, and those allow the agent to work on all of them no matter how long it takes, no matter whether the limits of the context are reached, and no matter whether I do it all in one or multiple sessions. Those tasks are also generated with Taskmaster. And now we are ready to develop something. When we develop something with a colleague that just joined the team, we normally do not trust that person and might ask them to explain what they're doing. The same applies to AI. Most of the time, we are instructing AI to develop a feature or a part of a feature, or to fix a bug, or to perform some operation, or something similar. Agents, in turn, are writing code for us and performing some actions. And hopefully, you will be reviewing all of that. You do not let your agent or agents run wild, right? That's the next rule. Do not trust AI. It's great. It speeds us up, but it is not perfect. Always review changes it makes and the actions it performs. You can do it in real time as they are happening, or in bulk at the end of an autonomous process if, for example, we are using GitHub Copilot coding agent or Cloud Code GitHub Actions or something like that. That's up to you. As long as you review what is done, you should be fine. Now, sometimes you will not be able to figure out the intention behind the change. Sometimes you will be confused and fail to understand what was done. And that's okay. When that happens, do not be ashamed to ask the AI to walk you through what it did and explain why it did what it did. Ask it. The next one is to not accept changes until you think, or I think, or we think a specific block of code is operational, and more importantly, to accept them once something is done. The longer we delay accepting changes, the more difficult it will be to spot what changed in the last round agent made. So accept changes before requesting a new round of changes, unless your review detects issues or tests are failing. That accepting changes will make it easier to spot what the new changes are. The most effective approach for me is to make minimal changes to the code, run tests, confirm that they are successful, review it myself, and finally accept them. Do that cycle on smallest amount of changes you can think of. Okay, so what's next? Yeah. AI will sometimes get confused, or it will go into a loop it cannot get out of, or you might feel that you're not progressing. When that happens, revert all the changes and start over. Do not be afraid to instruct the agent to execute git reset. AI makes us work faster. Unlike before, when we would not start over because that might mean losing hours or days of work, if we start over with AI, we lose much less time and we are likely to get to where we want to be sooner, equipped, assuming that we are equipped with what we learned and doing it all from scratch. You will know better what to ask for, and AI will not be confused with the ongoing implementation. Now, let's switch into memory and context tips. Context and memory of agents are the key to success. So that's the area where we might want to put an extra effort. To begin with, I recommend that we clear the context, or to be more precise, to start new sessions often. The longer AI works, the bigger its context is, and over time, that context will get compacted multiple times until eventually it becomes a pile of garbage AI cannot deal with. You will notice degradation in the quality of the output. If you're using something like Taskmaster that tracks your progress, understands dependencies between tasks, and keeps updating itself with relevant information, we can start a new session after each task related to a feature is finished. If that's too much for you, then at least make sure to start a new session every single time you start working on a new feature, and try to limit the scope of a feature as much as possible. Next, I recommend to instruct the AI to memorize common instructions. For example, when I say that we are done or any other similar phrase, the agent knows from memorized instructions that it should stage all changes, create a branch, run all tests, push changes to that branch, create a PR, request a review, analyze the outcome, implement suggestions, and other tasks related. In this case, with my end of work process. Now, to be clear, we can accomplish a similar result with cursor rules or Claude code, custom commands, or other types of custom prompts. Still, memorizing what to do on specific instructions or outcomes is, in my opinion, more effective. To begin with, that avoids us being locked into a specific agent, and it is often more natural than vibe coding and applies to a wider set of cases. What else? Yeah, since we're talking about memory. Update memory whenever AI does something wrong. Agents will often autocorrect themselves, but that is a waste of time. The more often they do the right thing from the start, the faster we'll get to where we want to be. For example, if I see that the agent is using a wrong command to build the app, I will tell it what the correct command is, and in the same prompt, tell it first to memorize that for the next time and then execute the correct command. Finally, models will often work with wrong or incomplete or outdated information about the tools or libraries or whatever else they're working with. It is useful to instruct the agent to read the docs before performing any actions or making any changes to the code. I find context 7 to be very useful for that, and have a rule as one of the memorized instructions that it should use context 7 whenever it needs to learn about something. Search for information on the internet is a fallback if context 7 does not have the info it needs. By the way, if you haven't used context 7, you might want to watch that video over there. The link is in the description. Okay, there's only one group of best practices or rules left to explore. This one could just as well be called those that are important, but I don't know where to put them category. It's a mixed bag. Before AI, we might have had a discussion whether it is better to architect applications as monoliths or microservices, whether we should organize apps in different repositories or shove it all into a big monorepo. I was in the camp of people advocating for microservices with each being in its own repository. And you, on the other hand, might or you might not fight me on that one. With AI, however, it is clear that microservices and separate repositories are a winner. The reason is simple. The smaller the code base, the easier it will be for AI to digest it, to keep the context with everything it needs, to work effectively, to make fewer mistakes, and to keep the number of tokens it uses, those that you pay for, at the minimum. Now, I understand that rule might not be applicable to existing applications and that you might not want to refactor them, at least not right away. We do what we can. However, if you're starting a new project, organizing it in a way that the code base is relatively small is critical. So, the first rule or a best practice is to keep code base small. Now, what I'm about to say is probably something I do not have to tell you, but here it goes just in case. Always, and I repeat, always test everything. Instruct the agent to always write tests and to always run tests every single time it finishes working on a feature. If it takes too long to run all the tests, it can run a subset related to the changes. In any case, it should be writing tests. You should be inspecting that the tests really reflect the features you are working on, and it should run tests to confirm that everything works. And it should do all that all the time. Speaking of tests, I find that functional tests work better with AI workflow than unit tests. AI is writing a lot of tests and even more unit tests, and that's fine, but also hard for us humans to validate. Functional tests are easier to understand and tend to work better as a validation that a feature indeed meets the requirements and works as expected. Next, do not assume that you'll always use the same agent or the same model. AI space is changing very fast. Only recently I was using Sonnet 3.7 only to switch to Gemini 2.5 because it was noticeably better, and a week or two later to Sonnet 4. I started using AI through GitHub Copilot in VS Code only to switch to Klein, which was great but too expensive, so I switched to Cursor, and I'm going back to Copilot, and I'm probably going to regret it, but that does not matter. What does matter is that I'm changing agents and models all the time. And on top of all that, I tend to use Cloud Code when working primarily with operations. Due to so many changes of models and agents, I learned that it's always better to use agnostic solutions when possible. For example, I could keep memory in Cloud-specific or Cursor-specific format, but that also means that it would be harder for me to switch from one to another. That's why I use Memory MCP for that and Taskmaster for PRDs and tasks orchestration. Similar can be said for many other features of those agents and sometimes models. If there is a good agnostic way to do something, use it, do it. Another important rule is to always ask for a second opinion. That could be from your colleague or from a different AI agent or your mom. I am still torn between GitHub Copilot, Code Review, and Code Merge. In any case, when I'm done, I create a pull request, someone or something reviews that pull request, and the agent I'm using analyzes the suggestions and implements those that make sense implementing. It's nice to have that additional safety, which, if you're doing it with AI agents, does not take more than a few moments, except when we really mess it up. Finally, the last, but probably the most important rule is to always use thinking models. Cursor agent, for example, is set to auto mode by default. It's supposed to make decisions when to use a normal and when to switch to thinking models. And it's garbage. It's a way for Cursor to save on tokens, and it does a terrible job at that. The level of frustration and repeated work when using anything but thinking models is so great that it does not make sense not to use them all the time. If you haven't already, switch to Sonnet or Gemini or any other thinking model and use them exclusively. So, here it goes, all of them combined. When starting a new session, we should load all the instructions from memory graph. Once memory is loaded, we should fetch an existing or create a new PRD. Unless it is a trivial change, every development should start with a detailed product requirements document, as well as a plan of all the steps required to develop that PRD. Okay, next. Do not trust AI. And I repeat, do not trust AI while developing. Ask the AI to walk you through what it did, accept changes before requesting a next round of changes, and if AI gets confused, or it enters into a loop, or it does not keep progressing, we should not keep pushing, but revert all the changes and just start over. When it comes to context, and considering that it does not take long to reach the limits, we should start new sessions often, and it is very, very beneficial to memorize common instructions so that we can execute them easily. Similarly, we should update memory whenever AI does something wrong so that we eventually teach it everything it should know about the project we are working on. Finally, to avoid making mistakes due to outdated models and lack of knowledge about specific libraries and tools, we should instruct the agent to read the docs. And on top of all those, we should keep codebase small and always test everything. There is actually more. Given how fast AI space is changing, do not assume that you'll always use the same agent or the same model. Once we are done with development of a feature, we should ask for a second opinion, probably from another agent. And finally, and this is really finally, always use thinking models. Do not fall into the trap of letting your agent select model for you. Thank you for watching. See you in the next one. Cheers.